you recall, we had talked about two different ways of doing complex areas, cutting them into pieces and adding them together, which would be tough to do here. The second way was filling in the missing pieces and subtracting out the pieces that are missing then later. So for this one, we can fill in these missing pieces to make a big rectangle. And then subtract out that quarter circle and that triangle later. So the first step is to find the area of the bigger rectangle. And to do that, we need to know the dimensions. Well, we know that this is 8 plus 22, or 30 inches total. And across here, can anybody tell me what that has to be? Well, it's 22 to here. Can anybody tell me what this is? 8. So then what does this have to be? 8. Because that's a circle, the radius has to be the same in every direction. So then that's 28 plus 8 makes this 36 inches total. So the area of the big rectangle is 36 inches by 30 inches, which is, what, 1,080 inches squared, I believe? Now we need to subtract out the missing pieces. We have this triangle here that is 8 inches by, what's this dimension here have to be? Well, 36 minus 21 leaves us with 15 inches. So that area is 8 inches by 15 inches. What do we have to remember to do to it? Divide by 2. Why did we divide by 2? Because it's a triangle, right? So 8 by 15 divided by 2, that comes out to be 60 square inches that we have to subtract out, putting us at 1,020. But we still need to subtract out this quarter circle up here. It has a radius of 8. So the area of the circle is pi times radius squared, so pi times 8 squared. But it's a quarter circle, so we're going to divide by 4. So that comes out pi times 8 squared divided by 4 is what, 50.24 inches squared. Now I believe my math lab always asks you to use 3.14 for pi. There is a pi key on your calculator. You'll notice when I'm calculating these, I'm using 3.14 in my head as pi. But if you use the pi key on your calculator, they come out to like 50.26. So be aware of that as you're doing my math lab, that make sure you know what it wants you to use for pi. So we have to subtract that 50.24 off of 1,020, which is going to give us 969.76 inches squared. Did anybody get that for area? A few of you. Good. Now then we need to find the perimeter we were asked to find for that. To find its perimeter, we're just adding together sides. We have 21 and 22. We're going to have to find this arc of a quarter circle a little bit. We have 28 and 22. So that's that piece from the circle, 28 and 22. And we have this slanted surface across here. We know how to find that slanted surface because this is a right triangle. This is A is 8, B is 15, and we're looking for the hypotenuse, which is C. So 8 squared plus 15 squared equals c squared. Now at this point, I'll let you in on a little shortcut on the calculator. What I would do is simply do the square root of 8 squared plus 15 squared equals c. So I'll just punch that in my calculator, the square root of 8 squared plus 15 squared. And we should get 17 for c. So that's 17 inches across there. So I'll fill that in. That's 17. Now I still need to find that quarter circle. To find that quarter circle, we think of it as being a full circle. The full circle would have a circumference of pi times diameter. Well, the radius is 8, so the diameter would be 16. That'd be 50.24. But since it's a quarter circle, we have to divide that by 4. It should be 12.56. So we add all of those up. We get what? 40. 122.56 inches, it looks like, is the perimeter. How many of you got that? A few of you? Okay. Any questions on here? Now that's kind of an extreme problem, a little bit tough for the ones we've done so far. And for homework, we really haven't had many of them yet. Those are going to be more on tonight's homework. So hopefully those become a little bit clearer as we practice them more. We're going to see that type of thing a few more times yet. For the second problem here, I asked, which is a better deal? One 16-inch diameter pizza for $12.80 or two 12-inch diameter pizzas for $14.50. There used to be a very common pizza chain that would do this. Oh, why would you get one 16-inch when you can have two 12 inches? That's 24 inches of pizza for just a couple bucks more. Well, it doesn't quite work that way. Just for the record, it doesn't pay to argue with the waiter either when they do that. So, the 16-inch pizza. What we're concerned about, of course, is the radius, which will be 8 inches. That's going to have an area of pi times 8 squared, which is going to be, what was that, 200.96 inches squared. Now they're charging $12.80 for that. What we need to do is $12.80 divided by, the rate would be square inches per dollar doesn't make sense. Dollars per square inch makes sense. So it's dollars divided by the square inches. 12.8 divided by 200.96 gives us 0.06369. So about 6.37, 6.369 cents per square inch. For the 12-inch pizzas, those are 12 inches. That means the radius is 6 inches. So that area is pi times 6 squared. Or 113.04 square inches. Now there are two of them. So times 2 is 226.08 square inches. We have to take that price of $14.50 divided by 226.08 square inches. To get 0.06414. That is, again, dollars per square inch. So we can see this is actually still cheaper up here for the one 16-inch pizza than it is for the two 12-inch pizzas. Realistically, they're very close in price. One is 6.37 cents per square inch. The other is 6.41 cents per square inch. So you're looking at literally less than a tenth of a cent per square inch. Any questions? Now, I realize the lectures have gotten ahead of the homework a little bit, and that's intentional so that I have more time to cover, to go over the areas and stuff multiple times rather than just once. Does anybody have any questions off the homework? Since the homework we had from Tuesday was basically from a week ago that we lectured on. Okay. So then, today we are going to continue with this area and perimeter. The next step, remember the area was started at the point. We moved it in a single direction to make a length. We move that then in a second direction to make an area. What we're going to look at today is what if we take that area. This is really a rectangle sitting on the surface, but we're looking three-dimensional now. What if we take that area and we move it in a third direction that is perpendicular to the first two? It creates a volume. So the volume, and in this case, we're just creating a box. The volume of that box depends on the area of the base. But what is the base? The base is just the shape that we started out with. In this case, it's the rectangle that's on the bottom of the box. However, the base will not always be on bottom. So the volume of that box depends on how big the base was, the area of the base, times the distance we moved it, which we usually refer to as a height. Now, most of you are used to seeing volume defined as length times width times height, which is true because the area of the base is just the length times the width. There's a very specific reason why I define volume in this way, as area of a base times a height, and that's because it allows me to find the volume of several different shapes, not just boxes. This formula here only applies to boxes. So let's take a look at some examples. By the way, if you're struggling to draw that box in 3 dimensions, draw a rectangle, and from each corner, just go up and over. Draw a second rectangle and connect the corners. We have a box. Let's say this box is 15 inches by 8 inches by 10 inches high. Now with a box, any of the sides of the box could be the base. And I could take this rectangle over here, and I could have moved that. I could have pulled that through space to make that box. Or I could have taken the front And I could have pulled that to make the box, as you can see. Typically, however, we go with the bottom as being our base. As you can see, that can be pulled, lifted up through to create that box as well. So when we're dealing with a box like this, we do usually refer to the bottom as the base. Now, of course, the top is the same shape. That's also considered a base as well. So to find the area of the base, that capital A with the little b subscript stands for area of the base. In this case, it's just the area of a rectangle. 15 inches by 8 inches. 15 by 8 is 120. Inches times inches is inches squared. From that, to find the volume, remember, volume is the area of the base times the height. So we take that 120 inches squared times the height of 10 inches. 120 times 10 is 1200. Inches squared times inches is inches to the third power, inches cubed. There's our volume. Now again, some of you are probably looking at it saying, well, would have been real easy to just go length times width times height. That's 1200 inches cubed. And that's true. But again, the reason why I define volume as an area of a base times a height is because we do run into problems like this. This is not a box. I could not do length times width times height to find its volume. But I can use the area of the base times a height. Now in this case, the base is this triangle on the end. You saw me take that triangle and pull it to create this shape like that. And that's what the base is that's the one side of the object that you can take and you can pull through the object to create the whole thing. Let's give you some dimensions on this. Well, let's say that this here is 12 feet, 5 feet, and 20 feet. So the area of the base here, well, the base is a triangle. To find the area of a triangle, it is base times height divided by 2, or 1/2 base times height. So here's going to be 12 feet times 5 feet divided by 2, which is 30 square feet. Then the volume is that area of the base, 30 square feet times. Now the height, we always think of height as being up and down, but in this case, it's not necessarily up and down. The height is the distance between bases. You know, this front here is a base, this back is a base. The height is this distance here in between them. So that's going to be the 20 feet. So we have 30 times 20 is 600. Feet squared times feet is feet cubed. So the volume is 600 feet cubed. Any questions so far? The other reason, another example of why this definition of volume as an area of a base times the height is useful. We can run into shapes like this. Let's say that this is 8 feet across the bottom, 10 feet tall. This is a cylinder. Here, the base is that circle, because that circle, if we take it, we can actually pull it, stretch it through the object to create the whole solid object. Okay, so we need to find the area of our base. Here, the area of the base, since the base is a circle, it's going to be pi times radius squared. So 8 is the diameter, the radius will be 4. So pi times 4 squared. That's 50.24. It's in feet, so that'll be square feet. The volume then is that area of a base, 50.24 square feet, times the height of 10 feet. So 50.24 times 10 is 502.4. Square feet times feet is feet cubed. There's our volume. So using that formula as volume being the area of the base times the height makes it very versatile. We don't have to, there are special formulas you could use for a cylinder, but we don't have to memorize those. We know how to find the area of a circle. We take that area of the base times the height. The next concept we want to talk about is surface area. And before I talk about surface area, I need to define it a little bit, define a couple other little things. Surface area is the total area of all surfaces, and I should say all exposed surfaces of a solid object. If I have two pieces that are together, let's say I have something like this. Oops. Where I have a box with another little box sticking out. That little surface here that's covered by this little box on it, that's not surface area because it's not exposed. Does that make sense? It's covered up with another part of the object. Now the next thing is the surface area is divided into two components. The first component we're already familiar with. The area of the base or bases. On a box, there's two bases. There's one on bottom, one on top. Everything we've done so far has two bases in it. But we will run into objects that only have one base to them. The other part is called lateral area. Lateral area is the area of the surfaces connecting the bases. So for this box here, that's the area of this end triangle, this end rectangle, I should say, the back rectangle, this end rectangle, and the front rectangle. The lateral area, there's the front rectangle, there's this end rectangle, there's this end rectangle, then the back. So all of those rectangles make up the lateral area. So let's look at a box and talk about surface area. So here's our box. Let's give it dimensions again. Let's go with 15 by 8 by 10, like we had before. The area of the base is 15 inches by 8 inches, 120 inches squared. That's the bottom down here. Now remember we said area of the base or bases. Does this have more than one base? Yeah, there's a top to it. So there's a second base that's also 121 inches squared. Now we have those lateral surfaces that we need to find the area of. We could find the area of each of these rectangles separately if we wanted to. And that would work out just fine for the box. But for other shapes, it might not be as easy. So what I'm going to do is just like I did in my illustration up above, I'm going to take those and I'm going to fold them out. The front here is a rectangle that is 15 inches by 10 inches. This end over here, well, it's still 10 inches high, but it's 8 inches. This end here, still 10 inches high, but 8 inches long. And then the back side, that's 15 inches by 10 inches high as well. And you see what we've created here is one large rectangle. And for most shapes, the lateral surfaces will fold out into one piece like this. And for most of what we're going to start out with tonight, it's going to be a large rectangle. So you see the size of that rectangle, the height of it is just the height of the box, the 10 inches. The length of it is the perimeter of the base of that box. We had the 8 here, 15, 8, and 15. So lateral area which I'm going to abbreviate as LA, is simply the perimeter of the base. Capital P with that little subscript B means the perimeter of the base times the height. So for this example here, the perimeter of the base is 8 plus 15 plus 8 plus 15, which is 46 inches. I use that to find my lateral area. 46 inches is the perimeter of my base, times my height of 10 inches. 46 times 10 is 460. Inches times inches is inches squared. So my total surface area, I add the base that's on bottom plus the base that's on top, plus my lateral area, gives me a total surface area of 700 inches squared. Now again, many of you are looking at that saying, well, why didn't I just find 6 rectangles and add them together? Why did I mess with this lateral area? Well, because once again, we run into shapes that don't fit into those nice, neat little rectangles. That look like this. To find the surface area of this, I'm going to find the area of the base. Well, the area of the base is just a circle. So that's pi times, what's the radius? Four feet. Good. The diameter was 8, so the radius will be 4. So it's pi times 4 squared, which is 50.24 square feet. Is there a second base? That's the bottom. Is there another end? Yes, the top is also 50.24 square feet. Now you can see here in this case, this lateral area that wraps around here is not a bunch of rectangles that we can calculate and add up. But we can, just like we did in that last problem, we can cut it up the side and unroll it. And as I unroll it, it becomes a rectangle. The height of this rectangle is still 10 feet. That's just the height of my cylinder. The length of this rectangle is the distance around. It is the perimeter of the base, or the circumference of the base. So the perimeter of the base is the circumference. That's pi times the diameter of 8, which is 25.12 feet. So up here, my lateral area is found by taking the perimeter of my base times the height, which is 251.2 square feet. Now I add together the area of the two bases plus my lateral area, I get 351.68 square feet is my total surface area of that cylinder. What do you think? Good stuff? I'm going to have you guys try one in your notes. I want you to find the total surface area here. I'll pause the recording and give you guys a few minutes to work on. So the first thing we really need to do on any of these is identify what is the base. The base here is either this triangle here or the triangle at the other end. They both can serve as the base. They both are bases. And then we're going to find the area of that base. Well, the area of that base is 12 by 5 and divided by 2 because it's a triangle. That gives us 30 square feet. Now there's a base on the other end as well. That's also 30 square feet. Now to find the lateral area, we first need to find the perimeter of the base. Here I've got 5 feet plus 12 feet. We need to know this distance here. Since that's a right triangle, we can find it. That is C, the hypotenuse of a right triangle. I'll call 5 and 12 A and B. So A squared plus B squared equals C squared. 5 squared plus 12 squared equals C squared. Gives me 25 plus 144 equals C squared. That is 169 equals C squared. Square rooting that gives me that is 13 feet across there. So this is 5 plus 12 plus 13 feet. Gives us 30 feet as the perimeter of our base. So our lateral area is the perimeter of the base, 30 feet, times that height of 20 feet, or 600 square feet, to give us a total surface area. Adding those three up, 660 square feet. How many of you had that? How many of you would have got there if I gave you a little more time? Okay. Any questions on that? Anybody really confused right now? Okay. I'm going to put a problem up here for you guys to think about. Then we're going to go to break. But what this problem is it looks like this. And for this problem, we have a distance here of 8 inches. This is 16 inches. And this here is 12 inches. I want to think about finding the volume. And the surface area. It's 4:18. It's a couple minutes early for break, but what I'm going to do is I'm going to give you a little extra time for break so you can take a break and come back and work on this. We'll talk about this at about 4:30, 4:32, somewhere in there. So I give you time for a break and a few minutes to work on. Okay, let's see how we did here. First thing we need to do is identify the base. Of course, the bases are either of these two shapes that are identical on the front and the back. So to find the volume, the first thing we need to do is find the area of the base. To do that, we're going to have to divide the base into two pieces. Piece 1 is a rectangle that is 8 inches on this side by, of course, this isn't going to be the full 16. We know this is 8 inches here, the other end of the rectangle. So that makes the radius of the circle half of that, or 4 inches. Well, that goes in all directions, so this is also 4 inches. So this is 12 inches. So that is 8 inches by 12 inches for that rectangle, which is 96 inches squared. The second piece then is the half circle. That is pi times, the radius is 4 squared, divided by 2 because it's a half circle. So pi times 4 squared is just the area if that were a full circle with a radius of 4. We divide it by 2 because it's a half circle. That comes out to be 25.12 inches squared. So we add that up. The area of the base is 121.12 inches squared. That makes the volume, the area of the base, 121.12 inches squared, times the height. Remember, the height is just the distance between bases, which is that 12 inches. Multiply that out is 1,453.44. And that is inches squared times inches is inches cubed. That's my volume. Now, for the surface, any questions on the volume? All right, for the surface area, we're going to have to do the area of the base, which we already found, 121.12 inches squared. There's one on the front, there's also one on the back. So there's another 121.12 inches squared. We need to look at the lateral area. Find the lateral area. We need to know perimeter of the base and the height. We have the height, that 12 inches, the same as the height we use for our volume. We need the perimeter of the base. The perimeter of the base, we have 16 inches. There's not 16, that's 12 inches we found that to be. 12 inches, 8 inches, and another 12 inches. Plus the distance around this half circle here. That distance is going to be half the circumference. So it's pi times the diameter. The diameter is 8 divided by 2, which is 12.56 inches. So we add that together, gives us the perimeter of our base is what, 44.56 inches. So we will use that to find our lateral area. It is the perimeter of the base, 44.56 inches, times, remember that height is the distance between bases is still 12 inches. giving us 534.72 inches squared. So we add up the two bases and the lateral area, which give us 776.96 inches squared for our surface area. Did anybody come up with that? That surface area is a little tougher to do. But as you can see, by defining the formulas for volume and surface area the way I did here, even an unusual shape like this, whether we couldn't hope to find a formula for that, we can still do it from those basic things. Area of the base times height for volume, then the pieces putting together the area of the bases plus the lateral area for the surface area. What we've been working with so far, you don't really know this term, but they're called prisms. A prism has two bases, two identical bases, and the lateral surface, lateral area is rectangles. What we're going to look at now is something that's not prisms, things that have one base. For example, a pyramid. Now the pyramids we're going to use are only going to have square bases, just to make it a little bit easier on ourselves. This pyramid here, let's say it has, let's give it a base of 24 inches. And a height of 35 inches. The volume of the pyramid still involves the area of the base. The area of the base here is just 24 inches by 24 inches, which is 576 inches squared. However, you can see that we can't just take that base and move it through space to make that shape. It doesn't make the pyramid, does it? Because the pyramid comes up to a point. It can't be just the area of the base times the height. When we were dealing with rectangles and triangles, when we had that rectangle to find the area of the triangle, it was just half of the area of the rectangle, right? Well, if we look at a box. If I cut a box in half, like this across these sides, what I get is not a pyramid, it's a wedge. The pyramid is smaller than that yet. I would have to cut it again, perhaps like this. Now, it's a pyramid. So the pyramid is less than half. The volume of the pyramid is less than half of the box. It's not a fourth because what we cut off here was just the wedge. It was just the little tip of the wedge. It wasn't the big base. This is one of the few times I'm going to ask you to just accept what I'm going to tell you for this formula, because to get the exact number would require calculus, and we're not going to go there. But the volume of a pyramid is equal to the area of the base times the height divided by 3. Now, the way I remember that, here, the area of the triangle was length times width divided by 2. We divided by 2, it was 2-dimensional. We divided by 2 to get from a rectangle to a triangle. This is 3-dimensional, so we divide by 3 to get from the volume of a box to the volume of the pyramid. So the volume of this pyramid is the area of our base, 576 inches squared, times our height of 35 inches, divided by 3. So 576 times 35 divided by 3. 6720. 6,720 inches cubed is the volume of that pyramid. For surface area. We still have the area of the base, 576 inches squared. But there is only one base here now, just the bottom. There isn't a base on the top anymore. The big adjustments come in finding the lateral area. In all of the other objects we found the lateral area for, like this one here, those lateral surfaces went straight up and down or straight side to side from one base to another. So the height of the object was the height of those lateral surfaces. Here, the lateral surfaces go at an angle. So the height of the lateral surface is not the height of the pyramid. We can find it by drawing in this triangle right here. From the peak of the pyramid down to the center. This dimension here is just the height, 35 inches. This dimension here goes from the center out to the edge is just half of the side, 12 inches. So what we're finding over here is called the slant height, or the slant. That slant is the hypotenuse of a right triangle. So we have 12 and 35, looking for the hypotenuse. So that slant squared is equal to 12 squared plus 35 squared. Now I'm going to take a shortcut, put it in my calculator as the square root of 12 squared plus 35 squared. And it gives me that slant is 37 inches, of course. Now the next adjustment to our lateral area comes from the fact that in all our other shapes, the lateral area was rectangles. In our prisms, it was all rectangles. In a pyramid, the lateral area is shaped like a triangle. So we're still going to use the perimeter of the base. The perimeter of the base here is just 24 inches times 4, because there's 4 of them, which is 96 inches. Or we could have done 24 plus 24 plus 24 plus 24. The perimeter of the base is 96 inches. So we're still going to use the perimeter of the base. So lateral area is that perimeter of the base, 96 inches, times the slant. But then we're going to divide it by 2. Because it's shaped like triangles. So now in a pyramid, the lateral area is the perimeter of the base, but instead of multiplying by the height, we multiply by that slant, and we have to divide it by 2. Giving us 1776, 1,776 inches squared as the lateral area for this shape. Which gives us 2,352 as our total surface area. Questions? Very similar to a cone. Or sorry, very similar to a pyramid is a cone. So let's say this is 16 inches across on bottom and 15 in, can't mix my feet in inches here, 15 inches tall in height. To find our volume, just like always, we start out with the area of the base. Now here the base is a circle. So we find the area of that base by doing pi times radius squared. How big is the radius here? 8 inches, right? Pi times 8 squared is going to be 200.96 inches squared. The volume, 200.96 inches squared times my height of 15 inches. But just like the pyramid, we have to divide by 3. So this is going to be 1,004 point, is that 0.8? Inches cubed is my volume. For surface area, we have the area of the base yet. 200.96 inches squared. There is only the one base on bottom. For lateral area, we need to find that slant. This is 15 here, that's still the height. The radius of 8 works. The slant is right here. So that slant squared is going to equal 8 squared plus 15 squared. Once again, I'm going to use a calculator shortcut. Get that slant is 17 inches. We also need to know perimeter of the base. Since the base is a circle, the perimeter of the base is a circumference. circumference is pi times that diameter of 16, which is 50.24 inches. So my lateral area is the perimeter of my base, 50.24 inches, times my slant, 17 inches. And remember, it's still shaped like a triangle, divided by 2. Gives us 427.04. So we add the area of our base to our lateral area. To get 628 square inches. Any questions? Let's talk about a sphere. A sphere has only 2 defining characteristics. The location of its center, which really doesn't affect its volume and surface area, and the length of its radius. So the only thing we have that we're concerned about for a sphere is its radius. Now again, I could show you where the formulas for volume and surface area of a sphere come from, but they involve calculus. We don't have time to get through a semester and a half of calculus to get to that point. So once again, I'm going to ask you to just trust me that these are the formulas. The volume of a sphere is equal to 4/3 times pi times the radius cubed. The 4/3 in that formula is just one of the constants that comes out as you do the calculus for that shape, for a sphere. Surface area is 4 times pi times the radius squared. So let's say we have a sphere with a radius of 6 inches. The volume, now it's easier to write this in the calculator if you do 4 divided by 3 for 4/3. Times pi is 3.14 times that 6 cubed. 4 divided by 3 times my 3.14 for pi times 6 to the power of 3. 904.32. That's in inches, so this will be inches cubed. My surface area is 4 times pi is 3.14 times 6 squared, which is 452.16 inches squared. Any questions? Now, as you can see, there are, even with me trying to keep the formulas simple and use the same formula for many different types, you can see there are a lot of formulas popping up here. I would recommend maybe you take like a back page of your notebook or the back cover of your notebook or something and get these formulas written down so you have them in one spot with maybe some diagrams so you know when to use which one. Because there's a lot of them, and searching through your notes to find them is going to take a long time. There is a new quiz due tomorrow, Friday, at 11:59 p.m. There is a new homework due for next Tuesday. You guys have a great weekend. Yes, sir. There. This time of night, my handwriting's sloppy. No